Hello and welcome to this video on question number 5, dynamics, Newton's laws of motion. This question that you see on the screen is from your AS Physics past paper. So this is a pretty long question which is split across two screens. If you want, you can take the snapshots or you can pause the video on each of the screens, solve the question yourself and then play the video again to look at the working and the mark scheme of it. So this is your screen 1. And here you have the screen 2. Before this question number 5 on dynamics, we have done 4 other questions, question number 1 to 4. The description, in the description box you can find the link for those questions to practice them and understand this topic very nicely. Alright, so I believe that you all have solved the question. You're coming back to the video to look at the working of it. And also please do not forget to subscribe to the channel if you find this channel helpful, if you find that this channel is useful for you to prepare for your exams. And do not forget to please comment in the comment box your feedback about the video, what you liked about the video, and if there is any suggestions for improvement, you can let me know. Alright, so let us start. A helicopter has a cable hanging from it towards the sea below as shown in this figure. A man of mass 80 kg rescues a child of 50.5 kgs. The two are attached to the cable and are lifted from the sea to the helicopter. Alright, so this is a situation very easy to visualize. The lifting process consists of a initial uniform acceleration followed by a period of constant velocity and then completed by a uniform deceleration. So what is happening during this course of motion? So initially there is an acceleration. Let's call it A. Initially there is an acceleration. Then there is a period of constant velocity. Constant velocity means that the acceleration is 0, followed by a period of acceleration which is 0 or constant velocity. And then finally there is a deceleration. There is a deceleration happening, which means that the speed is going down. So initially the speed is going up, speed remains constant, and then the speed goes down, which is deceleration. Let us understand what the question is asking us to do. Part A, calculate the combined weight of the man and the child. Easy question, and also it's 1 mark question. So what is the formula for the weight? Weight is mg. So what is the combined mass first? Let us find it out. 80 plus 50.5. This is the combined mass times g, which is times 9.81. Now you'll have to use your calculator. Take out your calculators, work it out in your calculators, and then let me show you the answer. I'll also show you the mark scheme here. Same thing. Your answer should be 1280 newtons, 1280 newtons. 1280 newtons. The unit is already given here. So first part was easy. Let us move on to the second part. Calculate the tension in the cable during the initial acceleration of 0.570 meters per second square. So initially when there is an acceleration, at that time you have to find the tension in the cable. Let me erase this information, not required now that we have understood, so I can remove it. So initial acceleration. So if you are given the initial acceleration, you're also given the total mass. You can find out the resultant force. You know that the formula for the resultant force is ma. This is the resultant force, right? And we also know that in this case the resultant force is how much? Say that the upward force is the tension, the downward force is the weight. There is an acceleration happening like this. So what is the resultant force? T minus the weight, tension minus the weight is equal to ma. So if you are wondering what is tension, what does this term tension mean? Tension is a name of a force. Forces, they come in different types. There are so many types of forces that we already know of. For example, gravity is a force, friction is a force, air resistance is a force, weight is a force, right? So many kinds of forces. Push and pull is a force, stretching, squashing, they are forces, right? Similarly, what is tension? Tension is a kind of a force that is created by a wire or a cable or a thread or a string. A force which is created by a wire, string or a rope is called tension. So here in this case, the motion, ultimate motion is in the upward direction. Ultimately, where is the motion happening? In the upward direction. So that means tension is greater than weight. So therefore, we subtract this weight. Tension minus weight is equal to the resultant force MA. So tension, let us start substituting the values. Tension is equal to MA. Mass is what? 80 plus 50.5, so which is 130.5 times the acceleration. Acceleration value is given to you in the question, 0.57, and when W will come on the other side of the equation, it will become plus the weight. W you already know, the combined weight, it is 1280. Now all you have to do is to use your calculator, work it out, pause the video for a moment, work it out in your videos and see what should be your answer. See, here also they are doing the same thing, exactly the same thing. So your tension is 1350. When you work it out, you'll get this answer. Alright, so this part is done. Let us come to the next part. Okay, the next part. So here the question starts from, calculate the tension in the cable during the period of constant velocity of 2 meters per second. So during the period of constant velocity, so when the velocity is constant, what is the acceleration? 0. Why is the acceleration 0? It comes from the formula of acceleration itself. A is v minus u over t. So when the velocity is constant, v and u will be equal. Why? Because the velocity is not changing. So the numerator becomes 0 over t. So the acceleration is 0. Simply and straightforward it can be proven. And also you know that when the velocity is constant, that means you are not increasing in your speed. So logically also, theoretically also, you know that you are not accelerating. Acceleration is 0. So let us use the same formula here. The resultant force, which is Ma, T minus W is equal to Ma. So T minus W, which is Ma becomes equal to 0 because acceleration is 0. It becomes m times 0. So this whole thing is 0. So tension is equal to the weight. And how much is weight? 1280. So the tension is 1280 newtons. Let us tally our answer with the mark scheme. 1280. So this thing comes from the concept of the terminal velocity as well. You can go to my video on the terminal velocity. The link for it I have put in the description box. Please go through it to understand all about the terminal velocity. Now the C part. During the final deceleration, the tension in the cable is 1240. Calculate this deceleration. Easy question. Again, it comes from this. F is equal to Ma. What is F? F is the resultant force, right? Now it is a deceleration. Deceleration. So in case of deceleration, calculate the resultant force. You are given the tension and the weight. What is the resultant force? Again, T minus W is equal to Ma. A is the deceleration. In this case, A value should come out to be a negative number. So tension is given to you 1240 minus the weight, tension is here, minus the weight given here 1280 is equal to m goes in the denominator 130.5. So clearly if you see here, you are getting a value of acceleration which is coming out to be a negative number because you're subtracting a bigger number from a smaller number. So work it out in your calculator, pause the screen for a moment and come back. If you see the same thing happening here, minus 0.31 meters per second square. Negative means that there is a deceleration happening. Negative acceleration is also called deceleration. Things about acceleration, how to work out with the formula for acceleration is explained in my theory video of acceleration. The link for it I'll also put in the description box. So check out the description box for the theory on the acceleration as well. When the acceleration is negative, and if you're calling it deceleration, then you ignore the negative sign and you call it, you just say the numerical value without the negative sign when you're calling a negative acceleration as deceleration. So your answer is 0.31. Let's tally with the answer. Yes. So let us move to the next part of the question. Calculate the time over which the man and the child are moving with uniform acceleration. So how was the motion happening? So if this is your man and your child, this box, say that, let's assume it as a box. Initially when it moved up, there was an acceleration, right? They started with the initial velocity of 0 because they started from rest, right? And finally what was the velocity? 2 meters per second. How do I get 2 meters per second? If you look at the question here, the period of constant velocity was 2 meters per second. This was the first part of the journey. During the first part, there was an acceleration, right? And in the second part, let me use the second part as a blue color. During the second part of the journey, they were moving at a constant velocity all throughout at 2 meters per second. And finally as well it was 2 meters per second. This was the second part of the journey when they were moving at a constant velocity. And finally the third part of the journey was a period of deceleration when they decelerated and finally reached a velocity of 0 meters per second. This was the third part of your journey. Now the question that they are saying is calculate the time over which the man and the child are moving with uniform acceleration. They are talking about acceleration. We are talking about the red part of the journey. So which formula do you think makes sense here to find the time? You have to find the time. You know the acceleration value. Acceleration value is given already in the previous question. You have calculated it. No, it was already given. 0.57 meters per second square was the acceleration. So you know the acceleration, you know the initial velocity, final velocity. Which formula does make sense? It is simply the formula for the acceleration. A is equal to v minus u over t. So which implies that t is equal to v minus u. What is v? V is 2 minus 0 over 0.57. Now you'll have to do it in your calculators and you should be getting a correct answer, which is 3.5 seconds. 3.5 seconds. Alright, so this was an easy question, just a 1 mark question. Now let us move to the second part of the question, moving with uniform deceleration. So they are talking about the third part of the journey, which is green. So what velocity was the initial velocity? Initial velocity was 2. And what was the final? I'm writing a u here, that's a u. And the final velocity was 0. Let us put everything in the formula. Acceleration is v minus u over t. So t is, how much is v? 0 minus u. Initially it was at 2 over the acceleration value, which was a deceleration actually. How much was the deceleration? Minus 0.31. Minus 0.31. If you clearly see, the numerator is a negative number, the denominator is a negative number, so your answer will be a positive number. Time has to be a positive number, really, logically. And if you solve it, pause the screen, solve it in your calculators, your answer should be 6.5. I'm leaving the calculation work for you all to do it. That's why I show the mark scheme so that you can tally the answers, but I'm showing all the methods and the formulas used correctly here to save time. So calculation work, please do it yourself on your calculator. That's the easy part of the thing to do for these questions. Okay, last part. The time over which the man and the child are moving with constant velocity is 20 seconds. So let us write down the details. So they travel at a constant velocity for 20 seconds. On this figure they are talking about, sketch a graph to show the variation with the time of the velocity of the man and the child for the complete lifting process. So let us do it. So time for the uniform acceleration was 3.5. So where is 3.5 on the graph? It's an easy question to do. The middle point, this is your 3, so this is your 3.5. And at the 3.5th second, what was the velocity? What was the velocity at 3.5th second? 2. So let me draw a line from 3.5 to 2. Let me make this as a dotted line because this is not a final graph. I am trying to arrive at the coordinates here. So what was happening? Initial coordinate when you started the journey, time was 0, velocity was 0. 0 and 0. When you started the journey, the coordinates were 0, 0. After 3.5 seconds of uniform acceleration, after 3.5 seconds of uniform acceleration, what was the velocity? 2. So what is the new coordinate? 3.5 and 2. It was a uniform acceleration, so it has to be a straight line. Uniform acceleration is represented by a straight line. And 3.5 onwards for the next how many seconds? 20 seconds. They were moving at a constant velocity of 2 meters per second. So what kind of a graph you'll get for a constant velocity? A straight line. So 3.5 plus 20. So what should be the next coordinate? 23.5 and 2. So where is 23.5? Starting from here. I'm sorry, let me take the straight line tool. So this is 20. 23 would be here, 0.5. I hope I've arrived at the correct number. For this I'll have to start from here. This is 30. 23.5. Yes. So this is your dotted line used for construction work, not a final graph. So this point here is 23.5 and 2. And after this point, how much time it took to decelerate? 6.5. So 23.5 plus 6.5 is how much? Plus. Let's add them. So 0, 1, so 10, 3, 30th second. So what should be the last coordinate? 30, and finally the velocity at the 30th second is 0. Right? So this completes your picture. So that's your final graph. The red solid lines that you see here, it is the final graph for the entire motion for the situation that you see here described in the questions, the velocity time graph for the entire situation. If you have any further doubts, please do mention it in the comment box so that we can have a chit chat there and I can clarify all your doubts. So here is the mark scheme. The last thing, have a look at the mark scheme and understand the mark scheme for yourself. It is really helpful. In the next video, we'll take up the next question, which will be question number 6. So therefore, stay connected.